Okay, notes 4-1, standard form of quadratic functions. And so in standard form, f of x is equal to ax squared plus bx plus c. I don't think this is anything new to you. Let's make a note of this where a, b, and c are real numbers. Okay, so if a, the number in front of the x squared, if a is greater than 0, the function opens upward and has a minimum point. And if a is less than 0, the function opens downward and has a maximum point. The y-intercept is the point 0c. We've done this countless times already, so if I want to find the y-intercept, all I'm doing is this, f of 0, but as it turns out, it is 0c. To find the roots or the zeros, or the x-intercepts or the solutions, you're going to set y equal to 0 and solve for x, which means you may have to do some factoring. Now, to find the vertex, and this is critical, to find the x-coordinate of the vertex is equal to negative b over 2a. That's equal to the x-coordinate of your vertex. So to find the y-coordinate, we're going to plug in negative b over 2a into the function and evaluate. Okay, so the equation for the axis of symmetry is x equals negative b over 2a. All right, so let's look at an example. So number one, for the function x squared minus 9, we want to find the following. We want to find the direction. Well, the number in front of the x squared, there's nothing there, so we understand that to be a 1, and it's positive, so that means my direction is going to be up. The formula to find the axis of symmetry is x equals negative b over 2a, but the problem is, if you notice, there's no b value. I could rewrite this, I don't want to confuse you, but I could rewrite this as x squared plus 0x minus 9, that's the same thing. And so my b value is 0, and so this would just be negative 0 or 0 over 2 times 1. Regardless, my axis of symmetry is x equals 0. Now, if I want to find the vertex, I'm going to find, well, we know it's just 0c, so the vertex is 0, negative 9, but I'm going to show you if you do f of 0, 0 squared minus 9 is still just negative 9. Okay? My y-intercept in this case for this graph, it turns out, is also 0, negative 9. Okay, now the roots, if I want to find the roots, I'm going to set f of x equal to 0. X squared minus 9 is equal to 0. There's at least 2 different ways you could solve this, but it is a difference of 2 squares. X minus 3, x plus 3 is equal to 0. And so we would get x equals plus or minus 3. Now, since we're graphing, I think it makes sense to write these as ordered pairs, negative 3, 0, and positive 3 zeros. Now, the domain for a quadratic function is always going to be negative infinity to infinity. All right, and my range, well, this one opens up, so that means the vertex 0, negative 9, that means negative 9 is a minimum value. So I'm going to start at negative 9 and I'm going to go up, and so I'm going to do bracket negative 9 to infinity. All right, so now let's sketch a graph of what this looks like. So the first thing I'm going to do is I'm going to graph the axis of symmetry. and the axis of symmetry is x equals 0, so it's just the y-axis. In this case, it's not always going to be like that. This is x equals 0. Now, I know my vertex is going to be on that axis of symmetry. And so the vertex is 0, -9, so I'm going to put it right here. And the only other 2 points I know are -3, 0, and 3, 0, so that would be here, -3, 0, and that would be here, 3, 0, and this would be my vertex, 0, -9. And so when I sketch it, it's going to look something like this. And you should label the points that you know, and you should draw your, you should go ahead and, when you're graphing by hand, you should go ahead and draw your axis of symmetry. Okay, so let's look at the next one. So we have -2x squared plus 4x plus 16. So this time, the number in front of the x squared, the a value is a -2. So because that's negative, that means it's going to open down, and that means my vertex is going to be a maximum value. Okay, if I want to find the axis of symmetry, x equals -b, so this is my b value, or the opposite of b, so that would be -4 over 2 times a, which is a -2, and if I simplify that, I get x equals -4 over -4, which is just equal to 1. So my axis of symmetry is x equals 1. So if I want to find the vertex, I'm going to plug in 1 into the function. So f of 1 is equal to -2 times 1 squared. Well, there's not much room to write there. Okay, so f of 1 would be -2 times 1 squared plus 4 times 1 plus 16. So that would be -2 plus 4 plus 16, which would be -2 plus 20, which would be a positive 18. So my vertex would be 1, 18. Okay, now my y-intercept is just going to be 0, and then whatever that c value is, or you can do f of 0 if you want to do that. And my c value is 16, and so my y-intercept is just 0, 16. All right, now the solutions are, I'm going to set the function equal to 0 and solve it. And so that's going to be -2x squared plus 4x plus 16 is equal to 0. I'm going to factor out the GCF, -2, so that's going to be x squared minus 2x plus 8 equals 0. So I have a trinomial. I'm going to factor that, and so the product would be 8x squared, and I made a mistake here, so this should be -8. So my product would be a -8x squared, my sum would be a -2x, and so my two factors would be -4x and positive 2x. And because if I'm looking inside the parentheses, that lead coefficient is 1, I can factor this mentally. negative 2 times x minus 4 times x plus 2 is equal to 0. And so my two solutions would be x equals 4, x equals negative 2. And so all I would have to do is just take the opposite of what's inside the parentheses. And so my two solutions, or my two roots, or x-intercepts, whatever you want to call them, are negative 2, 0. And because we're graphing, we're going to write these as ordered pairs, negative 2, 0, comma, 4, 0. The domain for a quadratic is always negative infinity to infinity. Now this time my vertex is a maximum value, so I'm going to go from negative infinity up to the maximum value, which in this case is 18, bracket. Okay, so let's sketch what we know. So let's sketch our axis of symmetry, x equals 1. Okay, we know the vertex is on that axis of symmetry, and so I'm going to say that the vertex is up here, so that would be the point 1, 18. We know the y-intercept would be 0, 16, so that would be 0, 16. I know that negative 2, 0 is a solution, and I know that 4, 0 is a solution. So negative 2, 0 and 4, 0, and then just sketch the graph. Polynomial. Okay, so last one, we're doing the same thing again. So we want to find the direction. The number in front of the x squared is positive. It's a positive 1. So that means that this is going to open up. So A equals 1, B equals 6, C equals 5. The axis of symmetry, x equals the opposite of b. So the opposite of plus 6 is minus 6 over 2 times a, which is 1. So that's going to be negative 3. So my axis of symmetry is x equals negative 3. My vertex is going to be on that axis of symmetry. So I'm going to find f of negative 3, which is equal to negative 3 squared plus 6 times negative 3 plus 5. And so that's going to be 9 minus 18 plus 5. So that's going to be negative 4. So my vertex is going to be the point negative 3, negative 4. My y-intercept, remember, is just 0, c. My c value is 5. Okay, so that's going to be 0, 5. My x-intercepts, so I'm going to factor this. The lead coefficient is 1. So we can factor it mentally. And so my product would be 5x squared. My sum would be 6x. And so that would be, and my two factors would be 5x and 1x. And so this would factor to x plus 5, x plus 1 is equal to 0. And so that means that my x-intercepts are x equals negative 5 and x equals negative 1. And so we're going to write those as ordered pairs because we're graphing. So that would be negative 5, 0, comma, negative 1, 0. Now my domain is always going to be negative infinity to infinity for a quadratic function. Now this time, since it opens up, the vertex is a minimum value. So I would start at -4, and I would go to positive infinity because we're going from bottom to top. Okay, so let's sketch what we know. Okay, we know the axis of symmetry is x equals -3. And we know that the vertex is -3, -4. So I'm going to say that's that point. I know I have x-intercepts at -5, 0, and -1, 0. So -1, 0, -5, 0, and I know I have an y-intercept at the point 0, 5, so about there. And so if we sketch this, it would look something like this. Okay, and that's how we graph quadratic functions in standard form.